Okay, so page 1. Let's start with y equals 2x plus 3. Very simple. You've been given three values of x. You need to find the associated values of y. How do you work out y? 2x plus 3 means you double x and add 3. So if x is minus 2, you do 2x, which is minus 4. Add 3, you get minus 1. You do the same thing for 0. Double x is 0, add 3 is 3. And for 2, double x is 4, add 3 is 7. These values now become coordinate pairs. When x is minus 2, y is minus 1. So we go minus 2, minus 1, and point. That's the point, minus 2, minus 1. Here's the point 0, 3. North along the corridor, 3 up the stairs, but you already know that. And the point 2, 7. And then if we had a ruler, we join them up. We just realised I don't have one. So I'm going to do it freehand, which obviously you shouldn't do. And you get a line that looks like that, more or less. Let's move on to the next bit. Gradient and intercept. Hopefully you're familiar with the idea of finding the gradient intercept from the form y equals and then something times x and something else added on. Whatever's next to the x, whatever x multiplied by, we refer to that with the letter m, that's the gradient. And whatever is by itself with no x by it, we refer to with the letter c, that's the y-intercept. Why is it that this is the gradient and this is the intercept? Well, the intercept is easy to explain. When x is 0, you get the y-axis. If you note back of the graph, for all the points on the y-axis, such as 0, 3, or 0, 2, or 0, 1, or 0, 0, or 0, minus 1, 0, minus 2, etc., 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 all these points along the y-axis have an x-coordinate of 0. Hence, the equation of the y-axis is x equals 0. But yeah, significantly, the y-intercept is the point at which x is 0. If you plug x equals 0 into this equation, then whether it's 3x or minus 4x or minus 5x, that becomes 0, and you're just left with y equals minus 10, or y equals 2, or y equals 20. So when x is 0, y is minus 10, thus the point 0, minus 10 is on the graph, and so the y-intercept is minus 10. So these ones are easy. When x isn't there, when x is 0, y equals 2. When x isn't there, x equals 0, y is 20. And when x is 0, we get minus 3y is equal to 24. And so if you rearrange that, minus 3y equals 24. You divide both sides by minus 3 and you get minus 8. There are other ways of doing that one. I'll come back to that. The gradient is slightly more difficult to explain, but not massively so. Basically, y equals 3 times the x value minus 10. Now, ignoring the minus 10, because that doesn't affect this particular aspect, for every increase in x, y is going to go up 3 times as quickly, because you're multiplying the x value by 3 to get the y value. That's what makes it the gradient. Here, you're multiplying the x value by minus 4, so an increase of 1 in the x value will result in a drop in, well, the y value is going to go down 4. What you multiply the x value by gives you the gradient. It's kind of like in sequences. If you have the sequences, you'll see later on, okay, let's pick a different sequence then, because I'll explain that later. If you've got a sequence like 4, 9, 14, 19, then you'd say that's kind of like the 5 times table, because it's going up. For the position numbers, the positions are 1, 2, 3, 4, and you call those n. You'd say these numbers are going up 5 times as fast, so you know that it's based on 5n, the 5 times table, but with 1 taken off, which makes this 5n minus 1. Well, if you renamed these, instead of n and 5n as minus 1, if you called these x and y, then y would be equal to 5 times x minus 1, if that makes sense. Because exactly the same logic is being applied. Every time x increases by 1, y is increasing by 5. So this is going up 5 times as fast as x, so it must be based on 5x. But instead of being 5, 10, 15, 20, it's 1 less than that. So this would be y equals 5x minus 1. So because the y value is going up 5 times as fast as x, that's how you get a gradient of 5. So here, y is going up 3 times as fast as x. Here, y is going up minus 4 times as fast as x, i.e. it's decreasing. And it's going down 4 times as fast as x is going up. Here, slightly less obvious because y and x are on the same side. So to make it y equals, we add 5x to both sides. We get y equals 20 plus 5x, which is why the gradient is 5 and not minus 5. And for this last one we have to do a little bit of rearranging. The easiest thing to do is to add 3y to both sides first. So we get 12x equals 24 plus 3y. That's not the only way of doing it. We could divide everything by 3 now, so we get 4x equals 6 plus y, sorry, 6, I mean 8. Oops. And then to get y by itself,